talking about factoring trinomials where a is equal to 1. And what that means is the standard form of a trinomial ax squared plus bx plus c. We're talking about where this number is equal to 1. But it really doesn't matter because no matter what number is there, we're always going to do them all the same way. It's just easier to see the pattern when a is equal to 1. Let's get started. Always going to start by tenting it and multiplying a times c. I have an invisible coefficient of 1 here, and so a times c is equal to 20. And we're going to circle our term. And we're going to use these two numbers to create what we're going to call a mod table. I'm going to do that here. I need two numbers that multiply to 20, so a times c, which is 20, and add to 9. So here's my b, here's my c, and let's start looking at multiples of 20, factors of 20, 2 factors of 20. So if we struggle with finding factors, we can use Desmos to help. And the number you're looking for factors of, divide it by x, doesn't matter what the graph looks like, convert that to a table. And we can start going through here and looking for numbers that add up. So -2 plus -10, that does not equal 9. So let's keep going down this table. I'm going to focus on the positive ones and see if I can find one. 1 plus 20 is 21. 2 plus 10 is 12. And I don't see anything else in here, so I'm going to keep typing in numbers. 3 is not a factor because it is a decimal. How about 4? 4 is a factor. Let's look at 4 plus 5. And you can see that's equal to 9, so I have found my numbers. So I'm going to go back over here. 4 times 5, 4 plus 5, this is equal to 20, this is equal to 9. I've found my two numbers. I'm going to use those two numbers technical difficulties here, so we're going to try this with another program. We're going to use this 4 times 5 to uncombine like terms. So when we multiplied this, we combined these like terms. We're now going to use it to separate this back out into 4x and 5x. So first goes first, x squared, last goes last, 20. And we're going to uncombine like terms along the diagonal. We're going to go through each column. Let's see if this works. Oh, it does. And see what they have in common. X squared and 4x have an x in common. Let's go through the next column. 5x and 20 have a positive 5 in common. Now we're going to go through the rows. This way, x squared and 5x have an x in common. And couldn't stay though. Let's see if this works. There we go. 4x and 20 have a 4 in common, plus 4. And we found our two factors. One is going to be along the top, x plus 5. And the other is going to be down the side, x plus 4. And we can check this in Desmos. This is the factored form of x squared plus 9x plus 20. Let's take a look at the graphs. Graph of the factored form cover the graph of the unfactored form, and it does. The other thing that we could do is multiply this back out algebraically and check that when you multiply with the box method, you get this when you multiply. I'll show you that in another one. Let's try another one. I'm going to tent it. Don't forget to take this negative sign with it. I have a 1 out here. 1 times negative 40 is negative 40. And my b term is negative 3. I'm going to use those to create my ma table. And I'm looking for something that multiplies to negative 40, but adds to negative 3. So I can start going through the factors of negative 40 and trying negative 1 and 40. That adds up to 39. Negative 2 and 20 adds up to 18. Scroll down a little bit. See if I can do this correctly. There we go. Negative 4 and 10 adds up to 6. Negative 5 and 8 adds up to 3. Well, I can tell I'm getting closer because I'm looking for negative 3, and that adds up to 3. So what about negative 8 and 5? Sure enough, negative 8 plus 5 is negative 3, and I found my two terms. I'm going to use those two terms to uncombine x squared minus 3x minus 40, uncombine into negative 8x, 5x. First goes first, last goes last. Uncombine like terms along the diagonal. Let's go through each column and see what they have in common. X squared and negative 8x have an x in common. 5x and negative 40 have a plus 5 in common. We're always going to take the sign that's closest to the box right here. Now let's go through the columns, the rows, like this. X squared plus 5x have an x in common. Negative 8x and negative 40 have a negative 8 in common. Again, this is closest to the edge of the box right here, so we're going to use the negative sign. One of my factors is x plus 5, and one of my factors is x minus 8. So the factored form is x plus 5 times x minus 8. And you can multiply that back out with the box or check it in Desmos. Let's try another one. Tent it. Take this negative with it. Times negative 15 is negative 15. Circle your middle term. Create your ma table. Looking for two numbers that multiply to negative 15 but add to 2. So I'm going to start going through the factors of negative 15, negative 1 and 15, that adds up to 14. Negative 3 and 5, that adds up to 2. So we have found our 2. We're going to use that to uncombine like terms. 5x, negative 3x. First goes first, last goes last. Uncombine like terms along the diagonal. Go through each column. Go through each row and see what they have in common. X squared and 5x have an x in common. Negative 3x and negative 15 have a negative 3. Remember, we're going to take this sign of the term closest to the edge of the box here. X squared and negative 3x have an x in common. This side's positive, so we're going to take this one, and this is positive, so 5x and negative 15 have a 5x in common. Factor 1, factor 2. X minus 3 times x plus 5. And we can check that in Desmos, or you can multiply it back out algebraically. I actually can show you guys that real quick. So you can set your box back up. X, and remember, it doesn't matter where we put things. So we could go one down the side, one up on the top. X times x is x squared. 5 times x is 5x. X times negative 3, negative 3x. 5 times negative 3, negative 15. First goes first. Last goes last. And combine like terms along the diagonal. 5 minus 3 is positive 2x. And the factored form matches the quadratic trinomial algebraically as well as graphically. All right, last one we're going to do. Find your B term, create your Ma table. Two numbers that multiply to positive 44 but add up to negative 15. And as you go through this, you're going to think, wait a minute, if I just do 1 and 44, that's 45. If I do 2 and 22, but how do I get a negative number? Well, two negatives multiply together to make a positive. So I think I have to look for numbers that are negative. I'm going to switch over to the negative side and see what happens. Negative 4 times negative 11 is positive 44, but adds up to negative 15. So I have found my two numbers. Use those two numbers to uncombine like terms along the diagonal. Negative 4x, negative 11x. First goes first, x squared, last goes last, 44. And I'm going to go through each column and look for like terms. And I'm going to go through each row and look for like terms. X squared and negative 4x have an x in common. This x is positive, so I'm taking the positive sign with it. Negative 11x and 44 have a negative 11 in common. Why did I choose negative 11? Because of this negative sign right here. X squared and negative 11 have an x in common. Negative 4x and 44 have a negative 4 in common. My two factors are x minus 11 and x minus 4. And this one I'm going to show you guys in Desmos. That is our factored form. Yay! Let's see, does the purple cover the green? It does. We did it. All right, guys, thanks for watching. I'm sorry about all the technical difficulties.